A sample proportion from a random sample provides a reasonable estimate of the population proportion. We do not expect the sample proportion to be exactly equal to the population proportion, but we expect the population proportion to be somewhat close to the sample proportion. The purpose of confidence intervals is to use the same proportion to construct an interval of values that can be reasonably confident contains the true population proportion. What is the connection to the sampling distribution? Sample proportions are estimates for the population proportion, so each sample proportion has error. For an individual sample, we will not know the exact amount of error, so we report a margin of error based on the standard error. Recall that the standard error is the standard deviation of sample distribution. We can view the standard error as the typical or average error in the sample proportions. To see how this works, let's return to a familiar sample distribution. Recall our previous investigation of gender in the population of part-time college students. We investigate these questions. What proportion of part-time college students are female? If we predict that the proportion is 0.60 or 60%, how much error can we expect to be confident in our prediction? We predicted the population proportion was 0.60 and ran a simulation to examine the variability in sample proportions for samples of 100 part-time college students. Here is the sample distribution from the simulation. Okay, let's look at it. So we see that we can be very confident that most samples of this size will have proportions that differ from 0.60 by at most 2 standard errors. For this simulation, the standard error in sample proportions was about 0.049. About 95% of the samples have an error less than 2 times 0.049, which is 0.098. If we use 2 standard errors as a margin of error, we can rewrite the confidence interval. So it'd be, as they show here, the sample statistic plus or minus the margin of error. Or in a sample proportion, sample statistic in this case is the sample proportion, and this margin of error we're going to say is 2 multiplied by the standard errors, as we mentioned above. The sample proportion plus or minus 2 standard errors, but 2 standard errors is 0.049. 2 times 0.049 is 0.098, as we kind of discussed in that paragraph above. Different sample proportions give us different intervals. For example, if the sample proportion is 0.57, the confidence interval is 0.472 all the way to 0.668. Here are our calculations. So as we said above, we take the sample proportion and you add or subtract the margin of error. The sample proportion that was just suggested up here was 0.57, so we put that where the sample proportion goes in this little formula, plus or minus 2 times 0.049, which we said above was 0.097. So you can take 0.57 and add 0.098, and then also 0.57 plus, or sorry, minus, we did a plus already, minus 0.98. Yeah, 0.098, sorry. The endpoints of the interval are the subtraction one here, 0.472, and 0.668. The confidence interval is from those two, the smaller to the larger, 0.472 to 0.668. Since about 95% of the samples have at most 9.8% error, we have a 95% confidence interval. Based on this sample, we say that we are 95% confident that the percentage of part-time college students who are female is between 47.2 and 66.8.